Alright, welcome to this particular module. Here in the last module what we have seen? We have seen how we can use multimeter to measure several components, right, discrete components. Also we have seen multimeter can be used to measure voltage, right, and we have seen a variable AC or variac, right. Variac can be used to change the voltage, AC voltage, and that AC voltage we were able to measure using the digital multimeter. Alright. Then we were at the end of that particular module, we were also able to see the frequency. Frequency we were able to measure around 49.8, frequency is around 50 hertz frequency, is also called line frequency, and the voltage was 230 volts, right. So, the voltage in India single phase is 230 volts AC and the line frequency is 50 hertz. Alright. So, in this particular module let us see extremely important equipment, and that is your power supply. So, again power supply can be AC power supply can be DC power supply, right. So, what is DC and what is AC? If in a very crude way to understand or to answer this particular question is that the AC would have 0 frequency, sorry, the DC would have 0 frequency, while AC you can change the frequency, right. So, when we measure the AC you have 50 hertz frequency, is not it, but if you measure DC it will have 0 hertz straight line, that is why we indicate DC by straight line, we indicate AC by sine wave, right. We can also indicate AC by triangle, we can also indicate AC by square wave. So, AC alternating current, DC direct current, right. Today in this particular module let us see this one, which is the DC power supply, alright. This is one DC power supply, this is another DC power supply. If you, this is fixed DC power source, you can change it little bit using this is extremely old. So, now why I have kept both the power supply here? The idea is lot of universities may still use this DC power supply, alright, or may use advanced version, I do not know, right, but those who are using this one it is okay, it is absolutely okay. Now, we have to first see what are the things written on this DC power supply, right. So, if we see first thing is CV, then we have FB, then we have plus 15 volts adjustable ADJ, minus 15 volts ADJ, there is a minus, there is a common, and there is a plus. These are the things given in this particular. There is a fuse, you can see fuse here, right, and then there is a mains. So, I have connected this, right, to the 230 volts AC, and now I am switching it on. So, when I connect it and I switch it on, you will be able to see the light here, right, this LED, correct. Now, what we will see? We will see how we can measure the voltage, what is the voltage right now, alright. So, measure this voltage, again Sitaram is here to accompany me, and he will be showing you how to connect this multimeter to the DC power supply. So, let us see. So, we have the DC power, we have the multimeter here, and he will connect it to the DC power supply. Alright. So, what is the voltage? 14.93 volts, 14.93 volts, excellent. Now, if I want to change this voltage, what is another way of changing it? I can change it using the screwdriver, right. This is because it is little bit old, we can see we can see the change. Let us try to change it, see we are changing it, change it in a different direction please. Yes, you see there is a change in the voltage. You can change the voltage by changing the knob, right, but instead of earlier time we had to use the screwdriver. Now, what is minus 15? If you want to measure minus 15 volts, how you can measure? This is plus 15 volts. You connect it to black and common is same. This is your minus 14.9, you can change it to 15 by changing the adjusting the knob, and you get close to 15 volts, close to 15 volts. right. So, this is minus 15 volts. Now, if we know, we have studied, right, in operational amplifier 741 we apply plus 15, we apply minus 15, that is your bias voltage given to your operational amplifier circuit. However, how to actually not how to use this or how to apply this DC voltage to the operational amplifier or to any circuit which requires the DC power supply, then this is the equipment which is your DC power supply, alright. Now, let us see a newer version of this, or better version of this. Here we can also see the value. Here we cannot see, right, because we have to connect a multimeter. Here we do not have to really connect a multimeter. Multimeter is connected to just to say that okay, whatever the value we are looking at here, is it similar to what we are looking at the multimeter. So, it will be close, but in this case the display is not there, However, you see this so big, is not it, so big, and is bulky, is heavy to lift it. So, again I have lifted it is wrong, I have lifted it when it is on, you see here it is on. You should not lift any equipment when it is in on state, when the power is on. You have to switch off the power, right, disconnect the equipment if possible, and then you can lift it, alright. So, point is these are heavy equipment. Why it is so heavy, why it is so bulky? Because you are the supply voltage that you are applying to this particular equipment is your 230 volts AC, 230 volts AC which I have applied, right, by connecting it to 230 volts, and I am converting this 230 volts to 15 volts or 15-16 volts. So, that means what, I have to use a function called equipment called or device called a transformer. First transformer, what it will do, it will convert your AC to step down, then it will give the AC which is lower, 230 volts to whatever voltage. Then we have to use another circuit, right, and using this transformer and the another circuit we can convert your AC to DC. What is the circuit, we will see, for you guys, or let me not give you as another question or keep you guessing, is a rectifier, right. Now, there are several types of rectifier again. So, when I use a word, like I said, every time and I am pressing it very heavy on each word, you have to go and you have to see what are kind of rectifiers, because it may not be covered in this particular lecture. So, when I say rectifier, we are using a rectifier. What kind of rectifier? Half wave rectifier, full wave rectifier, is there another rectifiers are there, right. Transformer, step down transformer, step up transformer, right. So, here step down voltage, we are stepping it down, right. Now, this is what, AC voltage sine wave, right, 230 volts AC, right, 50 hertz frequency, we are stepping in down to some voltage and then still AC. So, we have to remove the AC component and we have to make it DC. So, we have to filter out, right. So, you have to understand this thing. The point that I am making is this is a DC power supply where we cannot see what is a voltage, we cannot see what is a current, correct. So, when we cannot see what is a voltage, when we cannot see what is a current, what is an alternative way? We can use multimeter, we can again use the same thing called multimeter, beautiful. Now, let us move to the another one, which is this one. It is again bulkier, you see there is no improvement, all the way so bulkier, it is more bulkier than the previous one, because now we have two different sources here. You see we can apply through here or we can apply through here. Now, this is regulated DC linear power supply. If you see, read linear regulated means you can regulate it, DC is a DC voltage, linear power supply linearly increases when you increase the voltage, you will see, but that does not mean voltage and current had a linear relationship, that is not a case, okay, because current changes depending on the load that you are using it, what you connect it, that current will change accordingly. Now, so to start this one, right, let us first see each section and then we see what is the role of this particular DC power supply. So, again I am giving power to this particular DC power supply and I have given it to you here. So, now we can switch it on, can you please switch it on, excellent. So, what you see, here there is a 0 current is 0 because there is no load connected, you see there is no load connected. So, the current is 0. What is the power here? Here the power is or the voltage is 0 volts or 0.2 volts, here it is 5.22 volts, correct. Now, let us operate or let us see only one section. Okay. So, if you can still yeah, you can see very clearly here actually. So, what is written here? 0 to 30 volts and 3 ampere means maximum current can be 3 ampere. If it is 4 ampere, what will happen? It will burn, it cannot be operated, alright. So, maximum is 3 ampere, voltage from 0 to 30 volts you can change it. Now, there are this is what constant voltage, you see CEV, there is here constant current red color, right, LED CEC, there is a coarse, there is a fine, there is again a coarse, again a fine. So, that means that in voltage you can coarse change it, you can fine tune it, you can current also you can coarsely change it or you can fine it tune it. So, what does this coarse and fine means, we will see. So, if we change the coarse voltage, you will see, can you please change it? See, you can quickly see he is changing and you can get the voltage from 2, 3, 4, 5. If I want to fine change, like I want to fine tune it slowly, see 1, 5.4, 5.5, 5.6, 5.7. So, coarse cannot give you this fine tuning. Again, this tuning is the best tuning that we can avail from a DC power supply? No, we can even get a better tuning, The point is just I am telling you about the knobs, coarse knob and a fine knob, alright. Now, what is that again? There is a red and there is a black, and in the center if you see there is plus 15 volts 2 ampere common, minus 15 volts 2 ampere, which is similar to what we have seen earlier. So, let us first see just the voltage, if you want to measure the voltage using the multimeter, alright. These 6 volts that we can see, if you see the 6 volt side, we can see there is a 6 volts. So, let us see what we can what the multimeter shows us, what is the reading, and when we connect, see red to red, black to black, is it in DC power supply? 5.93, 5.92, right. So, the 5.9, 5.92 extremely close, or this is more accurate because this is like 2 digit we can see further after point. So, 5.92 volts, excellent. What is the current? Current is 0, current is 0. How about the another one which is 5.22, can you see 5.22 voltage? Again see how he is connecting, red probe, red 1 to red, black 1 to black, red to red, black to black, what you will be able to see 5.21, right, 5.21, very close, excellent. Now, if you want to see plus 15 volts and minus 15 volts, similar to last time that we have seen, what we can do? Can you connect plus 15 volts? So, plus 15 volts, again red and the common, which is your center thing, and what do you see 15.0. Now, this is constant, you see 15.0 volts already there, no need to change it, no worries. Minus 15 volts, just connect your red probe to, yes, green, and you can see minus 15 volts already there, plus 15, minus 15. In case of operational amplifiers, you can use directly these terminals and apply plus 15, minus 15 volts. So easy, isn't it? Now, what is another thing? Another thing is that at the same time we can use 2 voltage source, you see 2 voltages, different voltage we can apply, plus we can also apply plus 15, minus 15. So, advantage of this DC power supply is that we can use multiple circuits and you can use this as a source, that is the advantage. Okay. This is a locally manufactured DC power supply, but there are 2 advantages, in fact I can say multiple advantages. Is one is, see in this side if you see 0 to 30 volts 3 ampere, but if you go to this side maximum is 0 to 5 volts 1.5 ampere, right. Then you can apply plus 15, minus 15, right, that is another advantage. That means that you can use multiple circuits, and this is what your DC power supply means. So, now you all know. So, one thing that I want to tell you is, if you do not know what should be the current knob, always make it maximum, always make it maximum, that will save your circuit, alright. So, if you this knob, coarse knob, can you please make it to maximum? This is at maximum, alright. So, always keep it at maximum when you are operating any circuit, when you are using your DC power supply with any electronic circuit, then keep it at maximum. So, this is all about your DC power supply. One that we have seen is older version, another that we have seen is a newer version. The point is that any version you use, you should know what is the DC power supply, alright. And if the readings are not here, do not worry about it, you need a multimeter to understand or to check what is the voltage, right. So, easy, extremely easy to understand the DC power supply, alright. So, we will stop this particular lecture here, and in the next lecture let us see the function generator, alright, which is the another part or another equipment, and that also we heavily use when we do the analog circuits experiments. So, this is the starting, which is your DC power supply, and next module we will see the function generator, alright. So, this is the end of this lecture. Thank you very much.